Let's take a moment and look at some common valid argument forms. You'll want these to reference later as we're examining arguments and trying to determine whether they're valid or not. Some of these we've already proved. We'll call those out when we mention them. Others you'll prove as you work through the homework. These use just the same method as we've used so far to demonstrate that argument forms are valid. Each of these has a less formal name and a more formal name that you might see if you take a philosophy class that covers logic. And some of the formal names are in Latin, and you're not responsible for them. I won't ask you, what's the Latin name of this argument form. But I think they're fun, so I'm going to share them with you. So we start with two argument forms where we have a conditional, and then we say something about one of the statements in the conditional. We have what we might call direct reasoning. The Latin name for that is modus ponens, which I understand means something like the method of affirming. Here we have a statement of the form if P then Q. So a statement that tells us that whenever P is true, Q also has to be true. And then we have a statement that tells us that in fact P is true. And we conclude that in fact Q also has to be true. This is direct reasoning because what we're doing here is just directly applying the if-then statement. We also have an indirect way of applying the if-then statement, which we just saw in the previous video. We can call this indirect reasoning. Its Latin name is modus tollens, which I understand means something like the method of denying. This is the argument form we saw in the last video, where we have a premise that says, if P is true, then Q also has to be true. And then another statement that says, in fact, Q is false. And it turns out, as we just saw, that that forces P to also be false. So that's indirect reasoning. How do you know the difference between these? Well, you look at what the statements are. Is the second premise the same as the antecedent? Then you have direct reasoning. Is the second premise the negation of the consequent? Then you have indirect reasoning. Oh, but what if it's the negation of the antecedent? Well, it turns out that that's not valid, and we'll see that in just a moment. We have another form of argument that uses conditionals. In this one, we combine two conditionals into a third conditional. And its straightforward name is transitive reasoning. Now, that might already sound a little bit fancy because transitive is not an everyday word. Transitive means it just transfers this property of if-then. Because in this logic we have if P then Q, and then we loop around and say if Q then R. That's the same as just directly saying if P then R. The more formal name for this is hypothetical syllogism. And we will see this with conditionals stated as conditionals, or like all of our other argument forms with conditionals, we'll sometimes see these stated with universal statements as well. And then we also have the other argument form that we've already proved. This one does not have a conditional. It's an or statement. It's a disjunction. So we'll call this disjunctive reasoning, or more formally, disjunctive syllogism. Now, there is a reason that these two argument forms are both called syllogisms. Unfortunately, that reason is unlikely to become clear again at the moment. So, if you study formal logic in more depth, you'll play around more with these forms, and you'll see why it is that those are both called syllogisms. So in this form, we have a disjunction, P or Q, and then we have another premise that says that one of the things we're oring together is not true. And as a result, we conclude that the other one must be true. And we saw that in a truth table a little while ago. If one of them has to be true and it's not this one, then it's got to be the other one, is what this logical form says. And the truth table backs up that that really does work. Now these last two forms have 3 premises instead of 2 premises. And that's as complicated as we're going to get here. If we have an argument with more premises than that, chances are good that we can break it down into smaller pieces. So these last 2 slightly more complicated arguments, this one is called dilemma, and this one is called disjunctive elimination. And they're very similar to each other. They both start out with an or premise. They both start out by saying P or Q. In dilemma, we have a statement that if P is true, then R's got to be true. And a statement that if Q is true, then S has got to be true. And we conclude, then, that either we have P, and that leads to R, or we have Q, and that leads to S. That argument form is called dilemma. And you'll often hear, well, this is a dilemma, and it's because you have a situation where one of 2 things is true, and then both of those imply that, generally if you're talking about a dilemma, both of those imply that something that you don't want is true. Right, so that's usually what we mean when we say, well, this is a dilemma. I'm having to choose between these 2 things, but they both imply something that I don't want. Disjunctive elimination is very similar, except instead of applying different things, P implies R, and Q implies that same thing R. So that means whichever of P and Q you have, you're stuck with R. Right, those are very similar argument forms, except in dilemma, P and Q imply different things. In disjunctive elimination, they imply the same thing. So this is our library of valid arguments. Some of these we've already proved. Others we're going to go on and prove outside of lecture. You will want to have this reference handy because we are going to work more with these common valid argument forms that we do ultimately want to get into the practice of recognizing.